I'm just going to come right out and say it. Most developers right now, they're still using AI completely wrong.
Yeah, I mean, that's entirely accurate.
Right. Like, if you're listening to this deep dive, there is a really high probability that you're treating tools like ChatGPT as if they were just, Stack Overflow with slightly better prose.
Exactly. It's the classic copy-paste workflow.
Yeah, you hit a bug, you copy this massive snippet from your editor, you tab over to the browser, you paste it into the chat, you ask it to, find the null pointer exception, and then you just copy the fix and paste it back.
It's just so exhausting. I mean, it's a completely manual workflow.
It really is.
You're essentially acting as this human translation layer, right? You're the physical bridge between the AI's intelligence and your actual code base, just doing all this mechanical copying and pasting.
And the real paradigm shift happening right now, like the actual leap forward that is fundamentally changing our industry, it's not the jump from Googling error codes to asking an LLM.
No, not at all.
It's the jump from a chatbot to an ager. Because a chatbot gives you an answer, sure, but you still have to execute the work yourself.
Right, you still have to do the typing.
Exactly. But an agent does the work. It has hands.
And that disjunction, that difference between an AI that just dispenses advice and one that takes direct, environmental action.
Yeah.
That is the single biggest mental shift a software engineer has to make today.
Which brings us to the mission of this deep dive. Because this is Chapter 1 of a massive 19-part series that we are dedicating entirely to mastering Claude Code for any software engineer.
It's going to be a long journey.
Oh, yeah. But if you know Git, if you live in a terminal, and if you write code daily, this is built for you. We're not assuming, the esoteric details of LLMs or prompt engineering.
Right. You don't need a PhD in machine learning for this.
Exactly. Our goal today is just to understand that fundamental mental shift required to actually use agentic AI in your day-to-day workflow.
But we should probably establish some temporal context before we dive too deep into the mechanics.
Oh, right. Yeah, good call.
Because it is currently March 2026, and Claude Code, it ships updates weekly, sometimes even faster than that, honestly.
Yeah, the pace is crazy right now.
It is. So while the specific UI layouts or the exact flags on terminal commands or, the permission prompts we might mention later in this series, while all of that might shift around over the coming months, the underlying mental models we're dissecting today, those will remain the bedrock of your workflow.
The philosophy doesn't change even if the syntax does.
Exactly.
So to really grasp that philosophy, think about the traditional chatbot we've all been relying on. It's basically a highly intelligent but incredibly frustrating backseat driver.
That's a great way to put it.
Right. It's sitting in the back telling you, oh, hey, you should take a left here. Watch out for that edge case in the hydration logic. Your syntax is deprecated on line 42. But it absolutely refuses to touch the steering wheel.
Yeah, it just watches you struggle.
Exactly. But an agent, it climbs into the driver's seat, takes a wheel, steps on the gas, and actually drives the car for you.
And since the agent takes the wheel, we really need to examine what its driving actually looks like. I mean, we're moving from this abstract concept of, having hands to the granular mechanics of how those hands actually operate on your keyboard and in your final system.
Okay, so let's ground this in reality then. What does that agentic driving look like when I am staring down, a nasty silent failure in a distributed React state, and I just need my build to pass?
Let's break down the agentic loop. Think about your literal step-by-step process when you are debugging a failing test right now.
Okay, well, I run the test suite. It fails.
Right, and then
I read the error output in the terminal, copy the file path, open that file in my editor, trace the logic to find the mismatch, make a targeted edit, save the file, and rerun the test.
Exactly. And if it fails again, you just repeat that entire process.
Yeah, over and over until it turns green.
Right. So that loop reading context, taking action, checking the results, and repeating that is exactly what Claude Code executes autonomously without you ever switching windows or even touching your editor.
Okay, walk me through the execution of that loop, though. If I tell it to fix a bug, what tools is it actually utilizing under the hood to manipulate my files?
Well, you open your terminal and you just type fix the failing test in test_parser.py, and Claude Code just takes over.
Just from that one prompt?
Just from that prompt.
Yeah.
It utilizes its internal read tool to open the test file and actually parse the abstract syntax tree, or AST, to understand the structure of the code.
Wow, okay, so it's not just doing a text search.
No, it actually understands the structure. It reads the specific test that's failing, and then it reads the source code that the test is evaluating.
Right, so it finds the logical mismatch.
Exactly. Then it uses an edit tool to modify the source code, targeting those specific lines or functions. And finally, it uses a bash tool to run your test suite again.
Wait, okay. If it has a bash tool and an edit tool and it's just, spinning in the background, running commands and looping based on failures, how does it not just get stuck in an infinite loop?
That's the first thing everyone asks.
Because, if it hits a phantom bug or my environment is misconfigured, what stops it from just burning through a massive API token budget? Or worse, completely trashing my directory with guess and check code, like a hacky bash script?
That is the core developer paranoia, and honestly, it is entirely justified. But the difference between an agent and a hacky bash script is semantic reasoning and environmental observation.
What do you mean by environmental observation?
Well, a blind bash script executes predetermined steps regardless of the changing environment, right? It only knows it received a non-zero exit code.
Right, it just knows it failed.
But Claude Code actually reads the text of the standard output and standard error. It analyzes the stack trace.
Oh, I see. So it isn't just retrying the exact same fix over and over. It's reading the new failure and plotting a different trajectory.
Yes, it forms a new hypothesis. If the test still fails, it looks at the new error, literally explains to itself why the previous edit failed, and tries a different approach.
That's wild.
And crucially, it have internal token burn thresholds and loop detection heuristics. So if it attempts to fix the same block of code, say 3 times, and receives the exact same error structure, the agent halts its autonomous loop.
It just stops.
It stops and explicitly asks you, the human, for architectural guidance. It knows when it's stuck.
Okay, but if the tool is handling that entire micro loop of reading, editing, and running tests, my actual job description fundamentally changes, doesn't it?
Oh, completely.
Because if I'm no longer the one doing the physical typing and the endless looping, my brain cycles have to be reallocated somewhere else.
Yeah, your responsibilities shift from the micro to the macro. You're moving from thinking in keystrokes to thinking in intent.
Keystrokes to intent, I like that.
Because in traditional coding, your cognitive load is totally consumed by the how. Like, where do I hit the cursor?
Yeah.
Which file needs to be open? What is the exact syntax for a dictionary comprehension in Python versus JavaScript?
Yeah, you get bogged down in the mechanics of just typing the code.
Right. But with an agent, your cognitive load shifts entirely to the what. What should the end state of this system actually look like?
Okay, give me a practical example of how shifting to intent changes, say, a standard feature request.
Imagine you need to update an API client to handle rate limiting.
Okay.
Normally, instead of opening 3 different files, checking the documentation for the requests library, and writing a while loop line by line, you just tell the agent your intent.
So I just tell it what I want.
You literally say, add a retry mechanism to the API client with exponential backoff, a maximum of 5 retries, and a jitter factor. That's your intent. You define the parameters and the goal.
And it just handles the rest.
Claude Code figures out which files need to change, injects the backoff algorithm, and writes the unit test to cover the new behavior.
It really is the shift from being a solo guitarist to being a conductor.
Yes, that's the perfect analogy.
Because, as a developer today, I am the guitarist. I have to place my fingers on the exact frets. I have to pluck every individual note. I physically control the resonance.
You're making the music by hand.
Exactly. But with this agentic model, I am stepping onto a podium, waving a baton, and telling the orchestra, bring the strings in here, make the brass louder, slow the tempo down. I'm directing the entire system's architecture, but I am not physically playing the instruments.
But you have to remember, stepping onto the conductor's podium introduces a completely different set of challenges.
How so?
Well, directing an orchestra requires a really profound understanding of music theory. In software engineering, reviewing the code an agent generates is often far more difficult than writing it yourself from scratch.
Oh, that makes total sense. Because when you write it yourself, you intimately know every variable name and every edge case, right? You built the mental model line by line.
Exactly. But when an agent just dumps a complete feature into your lap, you have to load that entire context into your brain all at once.
You have to spot the architectural flaws in code you didn't organically build.
Right. If the agent writes that retry mechanism we talked about, but accidentally introduces a subtle race condition, or like a memory leak in an async loop, you need the system's knowledge to catch it during the review phase.
So it doesn't make you obsolete.
Not at all. You must understand your overarching architecture deeply to give clear directions in the first place. And you have to be absolutely ruthless in your code review. Managing an agent is not typing syntax, but it is equally, if not more, demanding.
Okay, so if my new job is being the conductor, the immediate question is what kind of baton I should be using. I mean, this entire series is dedicated to Claude Code.
It is.
But to understand why we're dedicating 19 chapters to this specific tool, we really have to look at the violent architectural shift that happened across the entire competitive landscape.
Yeah, if you experimented with AI coding tools, say 6 months ago, and dismissed them as toys, you were operating on severely outdated assumptions.
It moved fast.
Extremely fast. By early 2026, the industry experienced a massive convergence. Every single major player shipped a terminal-native coding agent.
The big four, right?
Yes. GitHub Copilot CLI, Cursor CLI, OpenAI Codex CLI, and Claude Code, they all run directly in your terminal now. They all read files, edit code, execute shell commands, and autonomously iterate on their own mistakes.
But wait, if they all possess that same basic agentic loop, what actually separates them? Let's break down the players. Copilot seems like the obvious starting point for most enterprises, right?
Yeah, GitHub Copilot CLI went generally available with its full agent mode in February 2026. Its primary market advantage is model routing.
What does that mean in practice?
And it's the only tool that allows you to hot swap between Claude GPT or Gemini under the hood, depending on the specific task you're doing. And because it integrates natively with GitHub's enterprise permissions, it is the absolute path of least resistance for large IT departments.
Got it. And then there's Cursor, which is fascinating to me because they essentially own the visual IDE space for AI coding, but then they deliberately step down into the terminal.
Right. Cursor shipped its CLI in January 2026. They recognize that power users require terminal access for complex multi-file orchestration.
You can't just do everything in a sidebar.
Exactly. They did introduce a cloud handoff feature where the CLI can offload heavy indexing to their servers, which is cool.
Yeah.
But their reality today is a hybrid workflow.
Meaning developers are using both.
Yeah, developers use the Cursor editor visually for like inline diffs and code base-wide searches, while simultaneously running Claude Code in the integrated terminal to handle the actual autonomous execution.
Okay, so if Copilot is relying on model switching for the enterprise crowd, and Cursor owns the visual interface, OpenAI must be taking a completely different architectural angle with Codex.
They are. OpenAI shipped the Codex CLI as an open-source project built entirely in Rust.
Rust. That's interesting.
Yeah, they engineered it specifically for speed and token efficiency because they utilize an autonomous sandbox model.
Wait, why does an autonomous sandbox model require building the CLI in a systems language like Rust? Why not just use Node or Python like the others?
Because the autonomous sandboxing approach relies on rapid, massive, parallel execution.
Okay.
You give Codex a task, and it spins up these ephemeral, containerized instances to brute force solutions. It's running the test suite dozens of times in isolated environments before presenting you with the final working code.
Oh, wow. So Node and Python would just be too slow for that.
Way too slow. They introduced too much runtime overhead for that kind of instantaneous multi-process spawning. Rust provides the memory safety and the sheer execution speed necessary to manage those ephemeral sandboxes.
That makes sense.
Plus, Codex natively supports Agents S.md, which is an open configuration format maintained by the Linux Foundation. So your project setup is portable across any compliant AI tool.
Okay, here is where I have to play the skeptic, though.
Go for it.
If all four of these tools run in the terminal, manipulate the file system, and loop through errors, isn't this just a Coke versus Pepsi situation? I mean, if the baseline functionality is identical, why does the specific tool matter?
That's a fair question, but the differentiation is no longer about the underlying capability. It is entirely about the philosophy of interaction.
Philosophy of interaction.
Yes. Codex is fire and forget. It runs away into a sandbox and comes back with a finished product. But Claude Code represents the highly interactive collaborator.
Meaning it talks to you while it works.
Exactly. It exposes its chain of reasoning in real time, and it intentionally pauses execution to request your input at critical architectural forks in the road.
Give me an example of an architectural fork where it would stop and ask, rather than just guessing.
Okay, so if you ask Claude Code to implement a caching layer, it will analyze your database connections and then actually stop to ask you, hey, do you want this Redis cache to invalidate based on a time-to-live expiration, or should I wire it up to invalidate based on database write events?
Oh, that's smart.
Right. It doesn't want to assume a massive structural decision on a major refactor. It wants confirmation.
It's literally pair programming with a hyper-competent junior developer who actually knows when to ask for clarification instead of just pushing breaking changes to staging.
Exactly. And that interactive philosophy is driving developers who prioritize code maintainability toward Claude Code. But beyond the collaborative approach, it really dominates in complex system-wide refactors because of two specific architectural features:
Which are?
agent teams and programmable hooks.
Okay, let's unpack agent teams first. How does an LLM manage a team of subagents without causing a catastrophic Git merge conflict? Because that sounds like a nightmare.
It utilizes native Git work trees. When you spawn an agent team for a massive feature, Claude Code spins up independent parallel sessions.
So they're working in different directories.
Essentially, yes. One agent might check out a work tree for your backend database schema, while another agent checks out a work tree for your front-end React components.
But how do they talk to each other?
They share a centralized context bus.
Yeah.
As the backend agent modifies a database migration, it broadcasts that schema change over the context bus.
No way.
Yeah, and the front-end agent receives that update in real time and adjusts its TypeScript interfaces to match before either agent even commits their code. They resolve dependencies across isolated branches simultaneously.
That fundamentally changes how quickly a single developer can push a full-stack feature. That's incredible.
It's a game changer.
But what about the programmable hooks? You mentioned earlier that we can't just trust an LLM to follow instructions perfectly. How do these hooks actually enforce rules?
So programmable hooks provide deterministic, system-level control over the agent's actions, and they operate below the natural language layer.
Below the natural language layer, what does that mean?
Instead of writing a prompt that says, please remember to run the linter and format the code before saving, you write a system hook.
Okay.
When the agent issues a command to write a file to disk, the hook intercepts that command. It physically pipes the agent's proposed code through your linter, like slint or rough.
Oh, so it catches it before it even saves.
Right. It parses the AST to check for banned imports or deprecated functions. And if the code fails the check, the hook throws a system error back to the agent, blocking the file write entirely, and forces the agent to fix the violation.
That is a hard cryptographic guardrail.
Exactly. It is the holy grail for compliance. You aren't relying on the LLM's behavioral adherence. You are enforcing compliance at the file system level.
But looking at this entire landscape, Copilot, Cursor, Codex, Claude, there is one glaring common denominator here. All of these tech giants, with billions of dollars in R&D, independently concluded that the terminal is the ultimate interface. Why the terminal?
Because the terminal is the lowest common denominator in software engineering. Every single developer, regardless of their tech stack, has one.
That's true.
Whether you are a Vim Power user, an Emacs purist, or you live entirely within IntelliJ or Visual Studio, the terminal is the universal layer.
It operates like the concrete foundation of a house. Like you can build whatever extravagant user interface you want on top of it, right?
Yeah.
You can have a beautiful IDE with custom themes, drag and drop sidebars, inline Git diffs, that is the living room with the expensive furniture. But underneath all of those aesthetics, the terminal is the concrete bedrock where the actual heavy lifting execution happens.
Exactly. And by building native to the terminal, these agents guarantee compatibility with any editor, any CI/CD pipeline, and any operating system.
Which is brilliant.
Now, to be fair, Claude Code absolutely offers IDE extensions for VS Code, Cursor, and JetBrains for developers who want that familiar sidebar interface.
Okay, good to know.
They also maintain a standalone desktop application for managing parallel tasks visually and a web interface.
Yeah.
And we will systematically cover all of those surfaces in later chapters.
Awesome.
However, the terminal represents the absolute fullest feature set. It exposes the rawest level of control, and it is where we will spend the vast majority of our time throughout this series.
Makes total sense. Well, we have poured the concrete. We understand the mental shift from keystrokes to intent. We've mapped out the converged landscape of early 2026, and we know exactly why the terminal is our operating environment. Now, it's time to actually start building.
Chapter 2 is where the theoretical framework becomes a highly practical workflow.
Yeah, in the next chapter, we are going to walk you through the precise installation process, guide you through running Claude Code for the very first time, and demystify the complex permission prompts that appear when the agent requests system access.
Both permissions are crucial.
They really are. We are also going to fix a real broken Python test together, and we'll show you how to utilize the checkpoint system to instantly roll back your directory if the agent hallucinates or makes a catastrophic error.
And honestly, we are barely scratching the surface of the architecture here.
Oh, I know. We won't cover it today, but over the course of these 19 chapters, we'll be dissecting plan mode versus execution mode, analyzing token economics so you don't accidentally bankrupt your API budget on a runaway loop.
Nobody wants that.
Definitely not. We'll be exploring cross-session memory and eventually integrating these agents directly into headless CI/CD pipelines. The scale of this workflow is massive.
It really is. But as we wrapped up this conceptual foundation, I want to leave you with a structural question to consider before we drop into the command line next time.
Ooh, what should we be thinking about?
We are entering an era where agents are actively learning our idiomatic patterns to write more efficient code.
Right.
But as millions of developers shift from typing syntax to orchestrating agents, a massive portion of the new code pushed to production will be generated by AI.
Which is happening faster every day.
So what happens to the software ecosystem in 5 years when a new generation of agentic models trains almost exclusively on code written by previous generations of agents?
Oh, wow.
Does human idiosyncrasy, for better or worse, just disappear entirely from our code bases? If you're no longer typing the code, but instead spending 90% of your time managing a digital junior developer, what happens to your own mechanical coding intuition over time? Do you lose your edge, or do you elevate to a pure systems architect?
That is a fascinating architectural paradox. Think about what happens to the human fingerprint in software, and we will see you right back here for Chapter 2.